Previously on Divelog.
She is an oceanographer, an analyst, an ocean engineer, a researcher, a scientist.
Careers in oceanography. I go, what? You can do this for a living? And I was like, I'm doing that.
I mean, you have been to Antarctica 7 times.
Yes, I want to hear about that.
A U.S. submarine was cruising along and they ran into it. Several people died. We know the surface of the moon and Mars much better than we know the bottom of the ocean.
Hey guys, thank you for tuning in to the Divelog podcast. Please do consider liking and subscribe to us. Click on the bell notification for alert of new content. Let us now continue with part 2 of our discussion with Professor Robertson.
What do we have next?
Current.
Currents. Okay.
It's another interesting topic for divers. Some people like to dive in current, some people do not like to dive in current.
Mm-hmm.
But generally speaking, Robin, how does current works?
So the big currents, there's two major ones, and one is driven by the wind.
Current is driven by the wind, that's one, okay.
Due to the Coriolis force, there's alternating bands of easterlies and westerlies in the atmosphere. All of those currents are very broad and slow on the east side, and they're very narrow and fast on the west side. And all of those currents were well known in the 1700s because the ship captains were using them because they could cut down the time.
Mm-hmm.
They could cut down the time to get from the U.S. to England using the Gulf Stream. In the North Pacific, it's the Kuroshio. In the South Atlantic, it's the Brazil current. And the Gula House current is really interesting because sometimes it just goes around in the ocean, and sometimes it sneaks around the end of Africa and goes up into the Atlantic.
Mm.
So those are the major wind-driven currents. Then there are the density-driven current, which is the thermohaline circulation. Now, those wind-driven currents happen pretty fast. Thermohaline circulation happens slowly. It takes thousands of years for this. It does, though, drive the currents in about 75% of the ocean, everything below 1,000 meters. Now, you guys are more interested in tidal currents, local currents, the tidal currents. In the Indonesian seas, we got the Indonesian through flow that's going through. So the Pacific is higher than the Indian Ocean, and when you have a change in water level, it wants to even out, and so there's an Indonesian through flow going from the Pacific to the Indian Ocean. And that flow has to go over through some narrow passages and over some sills. And so there's deep basins and there's shallow sills. The shallow sills block the deep water from the Pacific, so it's all surface type water, mostly surface type water, and it goes in. So you can see the temperature doesn't get cold like it. And that is actually part of the global thermohaline circulation. But, you're also interested in upwelling and downwelling, which is often wind-driven, not so much near the equator, but it's also topography related. Then the winds cause local currents. Big gyres are wind-driven. The big density currents are thermohaline circulation is density-driven. And then locally, we have tides and winds and topography. Divers aren't thinking about the big ones that I explained, but
correct me if I'm wrong, you're telling that the Pacific Ocean is going through Indonesia, and because it's from deeper waters, it comes out to Indonesia. That's why.
No, it's only the shallow. The deeper water is blocked. Pacific is higher than the Indian. So then there's this blockage trying to flow over here, and all this stuff is blocked. So only this makes it over, and it's trying to even things out.
But why is Indonesia having strong currents then? Because if it's shallow, it's so Indonesia is the block.
Indonesia is the block.
So that's
and
why.
if you put a hose down,
okay,
and you had some complicated rocks and stuff, and it's trying to flow through those rocks, then that's what the Indonesian through flow is doing.
But
it's blocking everything.
Why is Malaysia not experiencing
because we're
strong
actually
currents?
Where we're at is actually part of the South China Sea.
South China Sea. So it doesn't not flow into South China Sea at all?
Well, yeah, it comes into the South China Sea at Luzon Strait. And water from here goes through the Java Sea and it enters the Indonesian through flow. Sometimes. Not all the year. Sometimes it fluctuates with monsoons. Sometimes it's dumping fresh water, and sometimes it's not. It's going the other way a little.
Okay.
So yeah.
Interesting. Now I know.
What's your take on the recent bleaching event here? Actually, not here, throughout the whole world. The bleaching event, I mean,
Water's warm. It's global warming. Everything's warming up. The Great Barrier Reef has really been, I think it's 6 bleaching events in the last 8 years. And that takes 20, 30 years to recover. If you haven't dove there yet, go fast.
Usually, hot water travels from the equator to the poles, right? And cold water travels from the poles to the equator, the current. Am I right?
Yeah. When I was talking about the gyres and the Gulf Stream,
Yes.
that's warm water that's coming from the tropics and going towards, not to the poles, but going northward. And then
Yes.
it goes across the Atlantic. And that happens in the Pacific.
But for this bleaching event, we see hot waters are coming into the equator.
Yeah, well, the sun's here. I don't know where the hot water's coming from. I just think it's
Oh.
warming up from the surface.
Okay,
When
okay.
I looked at the bleaching here in May, I was just really surprised how much, because I dove in April and I dove in May, and there was a lot of bleaching. And it was the shallower waters and the tops of the corals that were bleached. So I think it's just the sun.
It's just that because of global warming, all the waters in the oceans are just warming up and they're just going everywhere.
Yeah.
Instead of what they used to be, going up to the poles or the
No,
north,
they're
as
still
you
going
mentioned.
up the poles. So I wrote one paper about the warming of the deep water. So warming of water that was 500 meters down. There's possibility that warming was deeper than that, but it didn't exceed the uncertainty of the instrument. The deep water is warming too, but most of the warming is in the top 700 meters. They're afraid that what's happening is the global thermohaline circulation will stop, and then the waters in the deep ocean will stagnate. And then warmer water is stable, so it won't mix down. And then the nutrients in the bottom waters won't come up, and then this might be better, but you won't see in fish.
Could you explain to us the significance of current? What does the current does to the world climate?
Well, it transports heat from the equator to the poles, so it warms up. When I was talking about what you asked me what the temperature was of surface water, that minus 1.89 water, that's warm. Because that is warmer than the air. The air could be minus 60. Ocean is giving heat to the atmosphere there. The actual warmest water is actually deeper, and we call it warm deep water, and it's warm because it exceeds zero. If you go and look at a profile of temperature, it'll go from 30 degrees down to 2, 3, 4 in 4,000 meters of water. It starts at minus 2, minus 1.89, and then it goes up to maybe 1 or 2, and then it goes down. The whole water column changes only by a few degrees. Or here it changes by almost 30. 30. So yeah, you can tell a polar profile from a tropical one easily, or even a temperate one easily.
Is it safe to say that for scuba diving activities and scuba divers, we are only mostly affected by the surface current, the wind-driven ones?
Yeah.
So are they predictable? Sometimes when we dive, we don't even know there's a current, but then suddenly the current will come and hit us, or sometimes even it changes direction.
Well, yeah, I think a lot of what your experience is tidal currents, and that's predictable. Yeah, wind is somewhat predictable, but how good are they at predicting the weather? They're pretty lousy. The reason is there's no Coriolis. Coriolis is zero at the equator, and storms form quickly, convection, and then they die. If you go, I lived in temperate areas most of my life. A storm is there for days, and they progress. So when we teach this, we say that without Coriolis, things flow from high pressure to low pressure. That makes sense. Down the hill. When you have Coriolis, they no longer go down the hill, they go around the hill, because there's a pressure gradient and the Coriolis, and they balance, and it's called geostrophic flow. When they balance, the current just goes around that high pressure. We know which direction it's going to go. And if you look at all those storms, they're not round, but they're funny shaped, off round. And And in weather maps, you see lows and you see highs, and that's what that is. And it's going around the hill. Otherwise, you go from high to low, it evens out, it's gone.
Then
The Coriolis is highest at the poles, 0 at the equator, negative in the southern hemisphere.
So are you saying that weather is more predictable when it's away from the equator than at the equator?
Yep. And it's more predictable if you got weather stations. So they are pretty good at the weather stations on the east coast of the U.S. than they are on the west coast of the U.S. because they got all those weather stations. But when you get across the Pacific, now with satellites going everywhere, it's helped a lot. So they've much better. But usually there's too much uncertainty to do more than 3 to 7 days. The navies are very interested in simulating those currents, and they use computer models to simulate those currents. At least the Australian Navy does. And they have a Department of Meteorology. They do ocean currents, and they do meteorology for all the services, because a lot of wars have been lost due to not knowing the currents or the waves. I mean, D-Day killed a lot of people. A lot of people were killed on D-Day because of more than from guns, were from the ocean.
Oceans. Does changing topography or bottom composition has effect on currents or tidal changes?
It has effects on tidal currents. It affects on currents, because if you have something this deep and you have something that deep and you're trying to force the same water through, it's got to go a lot faster through the shallow part than it is. Now, friction slows things down. Tidal currents will go up as they get in shallower water, and then the frictional drag will slow them down and get a bit.
Will it also change direction? Would be, right? Yeah.
We say the tide goes around in an ellipse. That ellipse is circular in deep water, and it's aligned with the topography as a long ellipse in shallow water.
So when you reclaim land, or when you are building ports, when you're shaping channel and so on, that change
And you
a
have
lot of stuff.
A lot of that's for an environmental impact. You hire an ocean engineer to model that for you to see what's going to be the change, and it may cause a stagnation place. So somebody may be dumping stuff, and all of a sudden, all that stuff is just sitting there because it isn't getting flushed out anymore. In Australia, they were sea ranching, so they were catching tuna. And they were putting them in pens and fattening up and then selling them because they couldn't get the big tuna.
Yeah.
But they didn't pay attention to the flushing, and there was too much poop, and it killed the fish, and they lost a lot of money.
Yeah,
so
by
they
the
have
millions.
to,
For sure,
they have to watch that, and so that's one of the things that we could do.
Let's say someone would like to plan a scuba diving trip. What is your recommendation? What do you think that they should check on prior to going to the location in order to have a good scuba diving experience?
I can sit there and give you a model or something, maybe. I think the best thing is to talk to the local dive shops, because they know the local area. And
they will always say, it's good now, come over, come over. The next thing you know. I mean, not to...
It's always a good day to dive.
Yes.
The best time to dive is now.
Yeah, it's never a bad day to dive. It doesn't matter what the weather is.
That is a good point, but they actually know the conditions and stuff. So you have to get them to tell you the truth. I don't know how you do that. If we don't know the topography, don't know the bottom, our models can be off. And they can be way off. And
before I forget again, I have got a questions. You were an ocean engineer before.
Yeah.
What is your take on artificial reefs? Pros and cons? Is it?
If they're not polluting, I'm pretty much for them. I mean, I'm finding more problems with building structures on beaches and problems with sediment transport. And some of the didn't do design well, like Santa Barbara, and they have to dredge it out every few months or else it closes up.
When you say ocean engineers can see whatever is put in the water, and you know where the effects leads to or where it goes to,
we're supposed to be able to model where
you
it goes.
will be able to model it.
Yeah.
Okay. And you did mention something like rust. What else
temperature, pollutants.
Is it difficult, or is it hard to?
And you can also do. They were doing algae. One of the things in Australia was connectivity between reefs. Is this reef? Can things from this reef, if they get currents, will they take them to this other reef.
Mhm.
So if this one doesn't have this animal, well, maybe this animal will move from there to there.
Recently, there was this idea just right here at Chiaman Island that they are going to build an airport right in front of the shore, the shorelines of the island. What do you think about that?
Terrible
Robin?
idea. I don't think they did an environmental study that would look at what that would do, the flow and affect all these dive sites and the pollution.
Will you think it will just only affect the area around the airport, or is the whole island in general?
I think it would affect at least half the island, the whole half the side. It would interrupt the flow. You put in something that's blocking the flow like that, you don't know what the downhill and sediment, sand transport is going to happen. And I mean, I like Tiaman Island, but I know that it's small and you don't have sewage treatment plants, and so there's got to be some runoff of things going on. I did a lot of work in the 1980s. There was environmental work because the east coast of the U.S. was so industrial. I was living on the east coast, and we were getting paid to monitor pollution from stuff. And I mean, one of the things was dredging harbors, which they do a lot. They dredged, but it had all this industrial pollution from chemical plants and stuff. So then they would dump it somewhere, and then they would dump some cleaner stuff on top. And then we would go out and measure the bottom and try to make sure that stuff was still there. When you brought up the sediment, it was just ugly. Nothing cool lived on there, so.
Okay.
And you certainly didn't want to eat any fish that ate that stuff, ate the worms and stuff that grew in it.
Dicky, I have a question for both you and me. We are both dive guide, dive masters. We are here at the dive centers. A lot of the customers actually sometimes ask, where are we going tomorrow? Where are we going the next day? Like basically choosing of the dive sites. So what is your take on this? How do you think dive masters choose their dive site? How do dive shop determine where to go the next day?
Well, what we normally do is we look at the weather forecast. First, we look at the weather forecast, right? Where's the wind blowing? How long is the wind blowing? How strong the wind will be blowing? Because that's going to determine how rough the sea is going to be. The next thing to do is to look at the tide to see the changes in the tide, how big of a changes, and so on and so forth, just to be able to estimate or measure up what kind of current are we diving in, right? So those are the things that we normally do, and then we plan on the dive site, taking into consideration the certification and the experience of the diver itself. And once we're on the dive site, we will again see it physically, because the forecast is just a forecast, and when you're there, you get to see it with your own eyes. And again, you will make decision. You might need to amend or you change your decision. Maybe you shift to another dive site and so on.
Yeah, apart from that, we also look at the moon phase.
Moon phase as well, yeah.
Yeah, to determine how crazy the tide is going to be. Like Robin just explained to us what the moon does to the tide.
Well, we're lucky
So
we
there are
don't
certain-
have the king.
Yeah, but there are certain dive sites that we cannot go during full moon and new moon. We know that.
Yeah.
These are some of the considerations that's on our mind when it comes to dealing with choosing the correct dive spots for fellow scuba divers. I need to tell this to people is because, I understand they come in for 4 days and there are certain dive sites that they want to hit. But sometimes they just end up going back disappointed because they can't go to that dive site.
Yes.
But I just want people to know that first and foremost, our own safety is the main priority when it comes to scuba diving. We do not want to have any incidents, however big, however small.
Yeah.
So safety is the main concern. It's not that we do not want to bring you there. It's just that there are a lot of times that condition might not be ideal for us to take you there. Some places the condition might be even more ideal to take you there. Things like that are put into consideration when it comes to choosing a dive site. Robin, why don't you give us some trivial, interesting fact about the ocean that most public do not know about?
Well, the average depth is 4,000 meters.
Average depth is 4,000 meters. Average, huh?
Average is 4,000.
So the world is filled with 70% of the earth.
75%.
75% of the earth is water.
4,000 meters deep.
And 4,000 meters deep. So, okay.
And the deepest is the Mariana Trench,
Uh-huh.
which is in the Indonesian seas.
And how deep is the
11K.
Mariana Trench? 11,000 kilometers.
No,
11,000 meters.
meters.
11,000 meters
kilometers.
deep.
Challenger deep.
Has anyone been to that depth? I mean, not as a diver though. Maybe any submarine has gone down to that depth.
Submarines don't go that deep.
Don't go that deep.
Our instruments go deep. And I know people have reviewed papers that they've sent instruments down that deep. But the problem is that when we measure temperature, we measure it to 1,000th of a degree. But to get the density right, we have to go to 1,000th of a degree. And salinity, we go to 1,000th of a, called PSU, but now they're not using units for salinity, but it's basically a parts per thousand.
Okay.
So we're going to 1,000th of a parts per thousand, and we need it that accurate. If you go down there, you need it more accurate. That's not good enough. You're going to get the same number.
Okay.
And we know that it gets denser with depth.
Okay.
We know that it has to get denser with depth because if it's lighter, it's going to overturn and come up. Floats up because it's buoyant. So we know it's got to go
11,000 meters.
The other thing is that we don't actually quote temperature, but we quote potential temperature because the pressure plays a role too. So we don't just use the temperature, we use temperature and pressure, which is called potential temperature. Otherwise, the bottom of the ocean is unstable and it should come up.
So back to the current. Is it because of the Mariana Trench? Mainly Indonesia is having strong currents because it's like a wall and then coming up.
No, it's like a trench.
Yes.
So it's got to go in.
And it has to go somewhere.
It goes in one end, it comes out the other, but not very much.
Okay.
Yeah.
Okay.
So the Mariana Trench is channeling water to Indonesia.
A little
Is that what you're
bit.
saying?
Once it's dense enough to go in there, it doesn't come out easily. Yeah. You know, but if something goes in, something has to come out.
Yeah. Yeah.
Okay.
Interesting.
I was telling Robin the other day, I found out the total amount of ocean water in the world. It is estimated to be 360 cubic miles worth of water.
I'm the one that's supposed to use miles. You have to use metric. Now, we use
I
metric.
read that. I
inside.
don't know. I just read it and then I just told you.
Okay. So we have
That
to
is
convert
ocean
it to
water.
Yeah, okay.
And also, now we're talking about fresh water. We only have access to 1.2% of fresh water in the world. That's why fresh water is such an expensive commodity right now. 30% of it actually is on the ground, fresh water. And 60% are actually from glacier.
In the ice sheets on Greenland and Antarctica, and also mountain glaciers. But the North Pole is over water, and the South Pole is over land.
So most of the glaciers we see are actually fresh water. Initially, I thought it was salt water because it's in the ocean, right? They're actually fresh water.
All the icebergs are freshwater, almost all of them.
Yeah.
But there's marine ice sometimes.
Sea ice.
Marine ice is different than sea ice. Sea ice has salt pockets in it. And when water freezes, it pushes away. The water molecules push away the salt. But pockets will form of super cold, super salty, and that will eventually work out into the ocean. And we call them brine pockets. The sea ice is soft, not compared to like lake ice. And I don't think you guys have ever walked on lake ice, but I have.
No.
And it you hear these cracks go, pew, and they zip across because the wind is pushing on it. It moves in and cracks.
The only ice we have is in the refrigerator.
Yeah. Okay.
Yeah.
So the glaciers come off. They're float. And so they're called ice shelves because they're a shelf with water underneath it. Seawater is warm. It's warm compared to this ice, and it melts the ice. But sometimes it changes the density. It gets lighter and it goes up, and sometimes it can refreeze. And if it refreezes, it turns it green. So you get green icebergs. And a lot of icebergs have ground up rock in them because it's come glacier. But they're all freshwater ice that's thousands of years old. And sea ice, they used to have it in the multi-year ice in the Arctic, maybe even 10 years. But now it's so much melting. And the Antarctic, there's only a couple places where there's multi-year ice, and most of it melts every year.
What is global warming doing to the ocean?
Warming it and acidifying it. Because the CO2 goes in, It causes it to be more acid, and the acid eats up shellfish. It eats up the shells of shellfish.
Will it do anything to human, as in divers? We're spending so much time in sea.
Well, it'll be warmer. I don't think the acidity is enough to melt us.
And of course, the melting of the glaciers and the iceberg will obviously increase the sea level.
Yeah, it'll increase sea level.
Since it is melting, the glaciers are all melting and so on, why don't they use that water?
They do. Yeah, there's places in the Andes that they're getting their fresh water is from glaciers, mountain glaciers.
Okay.
And the glaciers are melting, and then when that runs out, the city will have no water supply.
Mm.
The Himalaya, the ice is melting, and all these dead climbers that try to go up, they're popping out of the ice.
Popping out of the ice, okay.
Yeah, but that's the water source for a lot of India. And the other thing with global warming is it's not just warming, it's causing extremes. It causes extreme cold and extreme high. Weather system is becoming more unstable, so it's going to be more tropical cyclones, and it's harder to predict. And the tropical cyclones, there's more of them, and they're stronger. They are strengthened through warm water. Everything is more extreme and more unpredictable. People are working on it. There's limits to what we can do. We can't molecule every air model. We can't model how you walk around and cause air to move. And we're not going to model that for sure.
Yeah.
As an oceanographer for so many years, what is the most alarming changes that you see throughout your career?
The most alarming thing to me is the anti-science, the anti-vaccine, the anti-everything. No evolution. Evolution didn't happen. I mean, I've heard science, physics, they said it's just a theory. And I was like, is gravity a theory? Global warming is happening due to physical changes. There's physics that drives it, and that physics is happening. We first talked about global warming probably in the 1980s and 1990s. Here it is 30 years later, and there's still people denying it. So the denial of evolution, even though everybody who experienced that pandemic experienced evolution, that virus evolved into something milder that was more contagious but milder. This anti-science is, to me, the most alarming, because that is affecting both, global warming, blocking progress on that, blocking progress on vaccines. And I was in Malaysia during the pandemic. I was happy because you guys weren't anti-science. Asia put on masks. That was the first thing everybody did. Here, nobody thought anything of it. Yeah, you wear a mask. Fine.
So basically, it's the denial of what is going on that is the most alarming thing. That is
it's denial. It's saying it's not science. It's it's a faith.
What is your message to the viewers and the listeners out there?
Well, I think you need to take care of our ocean, and that means reduce your plastic use and reduce your emissions, your CO2 emissions. Reduce global warming, electric cars, and all that stuff. I'm going to have to change huge amounts of my appliances when I go back to Australia, because they've made some laws that are going to cost me a lot of money, but they're good for the planet. They're good for the next generations. And the anti-science is going to hit the next generations, and global warming is going to hit next generations. There's going to be more pandemics, and there's ocean acidification. There's overfishing is huge problem for the oceans. My generation and the one previous, they were mainly into extraction. They thought there were endless supplies of everything. There isn't. And my generation did a little bit and started some conservation. We got selfish too. My stepdaughter's generation and my nephew's kids are going to pay.
Speaking to the Malaysian who are interested in this field, how do they go about becoming an ocean engineer or oceanographer? And if that is something that they can or should consider, despite having the interest in it, how can they, I would say, prosper from becoming one?
So if you want to become a physical oceanographer or ocean engineer, you need to study physics or some kind of mechanical engineering. So I believe there's 3 physical oceanographers in Malaysia, and 2 of us share an office together. I still am an adjunct professor, so I still share an office. If you're in Malaysia and more people are interested in the biology, there's a lot of several marine biology, they call it marine science. Xiamen University, where I'm connected, I'm in a biological department. And also University of Malaya has a really good program. Terengganu and University of Malaya have field stations. Go and either get a basic biology degree or go get an undergraduate marine science degree if you want to go into marine biology. And believe me, I talked to 10 or 20 young people that want to be a marine biologist for every one that wants to be a physical oceanographer. The physics drives the biology because we calculate the currents and the waves and the tides, and that affects the biology. That affects the flushing for those guys who are putting aquaculture or ranching in. Malaysia raises sea cucumbers, and there's nobody doing it.
Where can they find job placements after finishing
they
these
get
studies?
a degree? Well, a lot of them go on to do graduate work. A lot of them go to China. A lot more money for oceanography in China than there is here.
Are you able to have job placement in oil and gas industry maybe?
Yep. That's, again, more physics, but yeah.
Okay.
But also, when Malaysia decides that the oil and gas needs to do environmental impacts, then you're going to need some biologists. All of our students have been placed. They've all gotten jobs.
In Malaysia?
In Malaysia or China. Now, I have students doing graduate work in the University of Delaware and one in Japan. They're doing graduate work and they'll have PhDs and yeah. The students I taught in Australia were all I taught at the Australian Defence Force Academy, so they were all in the military. So they all had jobs in the military.
In the military, yeah.
But most of them went into doing the meteorology. We were like a pipeline supplying that meteorology department that put a meteorologist on every ship because the Australian Navy decided it was important.
Normally, I will advise or invite the viewers and the listeners to contact Robin if they have any further questions. But Robin is retired. So if you guys have any questions in regards to the ocean that you want to discuss about, please do contact us, me and Dickie, or the Dive Log podcast, and we will try to accumulate the questions. And then perhaps if there's enough, we will invite Robin back here again for another session of our podcast.
The questions.
Yeah, and I'm sure Dickie and Adam will have more questions of their own.
We do.
Oh, you bet I do. I have a lot of questions.
And Dickie probably wants to see some pictures of Antarctica.
Yes, you can read my mind already.
They're on my computer.
Okay, yeah. I would really love to see them. Yes.
Yeah.
Robin, thank you so much for coming.
Well, thank you for
sharing
having
your
me.
knowledge.
Yes.
My pleasure.
It's really knowledgeable. I learned a lot from today's session, and I thank you for coming to the podcast and sharing your knowledge and experience with us as well.
And I wasn't allowed to mention equations, and I didn't. But I did mention
You
the
did a little bit, yeah.
Coriolis course.
We learned a lot about the oceans today. What drives the ocean? What moves the ocean and why and when and how.
Yeah.
I hope that this will be beneficial to all the listeners out there, especially to scuba divers. In order to become a better diver, you need to know the ocean. It's our playground.
Yeah.
We should understand it. Of course, safety-wise also. If you understand the ocean, automatically, you'll be safer. Once you know what's going on, you know how to react to it.
You are more aware of your environment.
That was my pleasure. One of the things we're expected to do called educational or public outreach.
Yes. Share our experience, give knowledge to others as well. Yeah.
Or perhaps you can put this session into one of your accolades also. I've been in the podcast, the Dive Log podcast, 2024.
Okay, when I want to
Public outreach via Dive Log podcast.
when I want to go for a job again, I'll do that.
We wish you all the best. Thank you again.
I wish you the best, and I hope to dive with both of you again.
Yes,
I haven't
for
actually
sure.
dove with you, but
Did we
that's
not?
okay. No, not for years.
We did once, I think.
Maybe
the last time I
once.
was here. But
I
yeah,
don't know.
maybe we should do more dives together. With that, guys, we hope this podcast has been very interesting and knowledgeable for you guys. As what Adam has mentioned, if you have any more questions, pertaining to the oceans and stuff, Please send us your question and we will get that to Robin and we'll cover those questions in the next podcast, hopefully.
Thank you guys for tuning in to our podcast. We have been receiving a lot of supports from our viewers. Everything that you guys say to us, we know that we are heading to the right direction.
Mm-hmm.
In the coming days, we will plan to do more podcasts that is educational to everyone and hopefully bring a lot of values to you guys. We'll see you in the next episode and stay tuned. Goodbye, guys.
Goodbye.